And here's another one that we dwelled on in week 4 with the colored liquid in glasses. Let me code up a program called swap.py. And in swap.py, let me set x equal to 1, y equal to 2. And then let me just print out an f string here. So how about x is this, comma, y is that. And then let me do that twice just for the sake of demonstration. And in here, recall that we had to create a swap function, but then we had to pass it in by reference with the ampersand. And like, oh my God, like that was kind of peak complexity in C. Well, if you want to swap x and y in Python, you could do x comma y equals y comma x. And now Python of swap.py. And there we go. All of that's handled for you. It's sort of like a shell game without even a temporary variable in mind. So what more can we do here? How about a few final building blocks? And these related now to files from that week 4. Suppose that I want to save some names and numbers in like a CSV file, comma separated values, which is like a very lightweight spreadsheet. Well, first, let me create a phonebook.csv file that just has name, comma, number as like the first row there. But after that, I'm going to go ahead now and code up a phonebook.py program that actually allows me to add things to this phone book. So let me split my screen here so that we can see the old and the new. And down here in my code for phonebook.py, in this new and improved version, I'm going to actually import a whole other library, this one called CSV. And here too, especially for people in data science and the like, really like being able to manipulate files and data that might very well be stored in spreadsheets or CSVs, comma, separated values, which we saw briefly in week 4. In phonebook.py then, it suffices to just import CSV after reading the documentation therefore, because this is going to give me functionality in code related to CSV files. So here's how I might open a file in Python. I literally call open. It's not fopen now. It's just open. And I open this file called phonebook.csv. And just as in C, I'm going to open it in append mode. Not write, where it would change the whole thing. I want to append, new line at a time. After this, I want to get maybe, how about a name from the user? So let's prompt the user for some input for their name. And then let's prompt the user for a number as well using input, prompting for number. All right, and now this is a little cryptic, and you'd only know this from the documentation. But if you want to write rows to a CSV file that you can then view in Excel or the like, you can do this. Give me a variable called writer, but I could call it anything I want. Let me use a csv.writer function that comes with this CSV library, passing in the file. This is like saying, hey, Python, treat this open file as a CSV file so that things are separated with commas and nicely formatted in rows and columns. Now I'm going to do this. Use that writer to write a row. Well, what do I want to write? I want to write a short list, namely the current name and the current number, to that file. But I don't want to use fprintf and %s and all of that stuff that we might have had in the past. And now I just want to close the file. Let me reopen my terminal. Let me run Python of phonebook.py. And let me type in, how about David, and then +1 949 468 2750, and crossing my fingers, watching the actual CSV at top left, my code has just added me to the file. And if I were to run it again, for instance, with Carter and +1 617 495 1000, crossing my fingers again, we've updated the file. And it turns out there's code now via which I can even read that file. But I can first tighten this up just so you've seen it. It turns out in Python, it's so common to open files and close them. You know, humans make mistakes. And they often forget to close files, which might then end up using more memory than you intend. So you can alternatively do this in Python so that you don't have to worry about closing files. You can use this keyword instead. You can say with the opening of this file as a variable called file, do all of the following underneath. So I'm indenting most of my code. I'm using this new Python-specific keyword called with. And this is just a matter of saying, with the following opening of the file, do those next 4 lines of code, and then automatically close it for me at the end of the indentation. It's a minor optimization, but this, again, is sort of the Pythonic way to do things instead. How else might I do this too? Well, it turns out that the code I've written here on line 9 especially, is a little fragile, right? If any human opens this spreadsheet, the CSV file in Excel, Google Spreadsheets, Apple Numbers, and maybe like moves the columns around just because maybe they're futzing, they save it, and they don't realize they've now changed my assumptions, I don't want to necessarily write name and number always in that order, because what if someone screws up and flips those two columns by literally dragging and dropping? So it turns out that instead of using a list here, we can use another feature of this library as follows. Instead of using a writer, there's something called a dictionary writer or dict writer that takes the same argument as input, the file that's opened. But now the one difference here is that you need to tell this dictionary writer that your field names are name and number. And let me close the CSV here. Name and number are the names of the fields, the columns in this CSV file. And when it comes time to write a new row, the syntax here is going to be a little uglier, but it's just a dictionary. The name I want to write to the dictionary is going to be whatever name the human typed in. The number that I want to write to the CSV file is going to be whatever the number the human typed in. But what's different now about this code is by simply using a dictionary writer here instead of the generic writer, now the columns can be in this order or any order. And the dictionary writer is going to figure out, based on the first line of text in that CSV, where to put name, where to put number. So if you flip them, no big deal. It's going to notice, oh, wait, the columns changed. And it's going to insert the columns correctly. So just, again, another more powerful feature that lets you focus on real work as opposed to actually getting tied up in the weeds of writing code like this otherwise. Questions on this one as well? No? Let's do, how about one more with a dictionary, only because I claim that these are the most useful of data structures. And let's go ahead and do this. With just those of us here, anyone following along at home, if you'd like to go to this URL for the moment, cs50.ly/Hogwarts, you'll see a Google form just prompting you for your house, so to speak, in the world of this universe. So if you've got your phone or your laptop, just go to this URL here, cs50.ly/Hogwarts. And what I'll do in just a moment on my machine is pull up the corresponding Google spreadsheet, which is a thing if you're familiar with Google Forms. And via this form, we'll have a whole bunch of data. And in this file, which I'll reveal in a moment, we'll see, hopefully, I see people logged in. Do we have, is this working? Come on. Is this URL working for you? Oh, really? Oh, shoot. OK, I know what happened. I did not create that URL. What is the best way to solve this? Carter, how quickly can you solve this? Is it solved? OK, hold on for 5 seconds while Carter is saving me some embarrassment. OK, so keep going to this URL here. What I'm seeing on my end very awkwardly is no one has submitted the form yet. All right, hopefully. What's that? You don't have access to that form? So this is going off the rails quickly? No, you don't. OK, how to fix. Thinking. 1 second. Oh, this is going to be stupid. OK, here, 1 second. Can I get the form? No, I don't. All right, this is watching someone struggle on the internet. OK, we're going to skip that example. And we're going to do the more dramatic ending instead. So how about this? All right, apologies. We'll ask you your house some other time. Let's come back to some final flourishes instead. So let me get VS Code ready to go here. Pretend that never happened. There's this one other feature now we want to introduce you to Python that exists in lots of languages. And this is where programming really gets powerful, especially for the purpose of collecting data, analytics, running numbers, data science, and the like, when you can actually use patterns to analyze data and extract information therefrom. So if you've got a large data set and you want to figure out some pieces of data from it, a regular expression is essentially a pattern in Python in lots of languages that lets you use certain expressions like these. A dot to represent any character, or a dot star to represent 0 or more characters, or dot plus to represent 1 or more characters, and some other somewhat cryptic syntax, admittedly. We're going to give you just a taste of this here as follows. I'm going to go back into my agree.py .py program, which previously looked like this, where I enumerated all of the possible values that I wanted to support when it comes to someone agreeing yes or no. Well, it turns out that I can actually do this in a more powerful way. I can tolerate really any word that might start with y or yes using a regular expression as follows. I'm going to do this. I'm going to first import this library, RE for regular expression. I'm going to then go ahead and say this. If a function called search in the regular expression library matches either this or this question mark, and I'm going to put some cryptic syntax in here, passing in s. And then I'm going to say print agreed. And else, and I'll explain in just a moment, re.search, quote unquote, no question mark $, close quote s. Then I'm going to go ahead and print out not agreed instead. And we're just going to scratch the surface here with this syntax. But regular expressions indeed define these special symbols that you can use to represent different types of characters. And so what I've done here is as follows. Suppose that I want to support either y or yes as possible answers from the user. This is a syntax you'll see over time, which is missing a close quote on this line, whereby I can express certain patterns. So here on line 7, I am going to have this library search for the following. Caret symbol here from practice means start at the beginning of the string. So the first character that the user types, start searching there. The $ means search all the way to the end of what the user has typed in. So let's put those aside. Caret is beginning, $ is end. They're not symmetric at all. It's just a weird choice of characters. Y means literally search for a Y. ES in parentheses followed by a question mark means that the yes can be there, or rather, the ES can be there, or maybe it's not. The question mark makes that pattern ES optional. And the parentheses indicate that it's just the ES that's optional, not the Y. Meanwhile, if I search for this at the beginning of the string all the way to the end of the string, search for NO, but the O can be optional, so alternatively just search for N. So if you've ever used like a Google form correctly, and you have been told that, wait, your Harvard ID or your Yale Net ID or your email address doesn't match a pattern, it's invalid, this is a taste of the kind of syntax that programmers at Google or elsewhere are using to validate input, trying to figure out exactly what you've typed in and whether it matches an actual pattern. And we won't spend a great amount of time on these here, but it's just to give you a taste of what you can actually do with features like these. But what we will do now is come full circle to some of the more sophisticated examples with which we began. And I'm going to go back over to my own Mac laptop here, where I've got my own terminal window up and running. And I was just going to introduce a couple of final libraries that really speak to just how powerful Python can be and how quickly you can get up and running. To be fair, can't necessarily do all of these things in the cloud, like in code spaces, because you need access to your own speakers or microphone or the like. So that's why I'm doing it on my own Mac here. But let me go ahead and open up a program called speech.py. And I'm not using VS Code here. I'm using a program called VI that's entirely terminal window based. But it's going to allow me, for instance, to import the Python text-to-speech version 3 library. I'm going to give myself a variable called engine that's going to be set equal to the Python text-to-speech 3 libraries init method, which is just going to initialize this library that relates to text to speech. I'm going to then use the engine's say function to say something like, how about hello, comma, world? And then as my last line, I'm going to say engine.run and wait, capitalized as such, to tell my program now to run that speech and wait until it's done. All right, I'm going to save this file. I'm going to run Python of speech.py, and I'm going to cross my fingers as always, and
hello, world.
all right, so now I have a program that's actually synthesizing speech using a library like this. How can I now modify this to be a little more interesting? Well, how about this? Let me go ahead and prompt the user for their name, like we've done several times here using Python's built-in name function. And now let me go ahead and use a format string in conjunction with this library, interpolating the value of name there. And at least if my name is somewhat phonetically pronounceable, let's go ahead and run Python of speech.py, type in my name, and
hello, David.
OK, it's a sort of weird choice of inflection, but we're starting to synthesize voice, not unlike Siri or Google Assistant or Alexa or the like. Now we can maybe do something a little more advanced too. In addition to synthesizing speech in this way, we could synthesize, for instance, an actual graphic. Let me go ahead now and do something like this. Let me create a program called qr.py. I'm going to go ahead and import a library called OS, which gives you access to operating system-related functionality in Python. I'm going to import a library I've pre-installed called QR code, which is a two-dimensional barcode that you might have seen in the real world. I'm going to go ahead and create an image variable using this QR code library's make function, which per its documentation takes a URL like one of CS50's own videos. So we'll do this with YouTube /xvfzo5pgg0. So hopefully that's the right lecture. And now we've got image.save, which is going to allow me to create a file called qr.ping. Think back now on problem set 4 and how painful it was to save files. We'll just use the save function now in Python and save this as a ping file, portable network graphic. And then lastly, let's just go ahead and open with the command open qr.ping on my Mac so that hopefully this just automatically opens. All right, I'm going to go ahead and just double check my syntax here so that I haven't made any mistakes. I'm going to go ahead and run python of qr.py, enter. That opens up this. Let me go ahead and zoom in. If you've got a phone handy and you'd like to scan this code here, whether in person or online, I apologize. You won't appreciate it. Amazing. OK. And lastly, let me go ahead, just because that feels like a really rude note to end on. Let me go back into our speech example here, create a final ending here in our final moments. And how about we just say something like this was CS50, like this. Let's go ahead here, fix my capitalization just for tidiness, get rid of the name. And now with our final flourish and your introduction to Python equipped, here we go.
This was CS50.
All right, we'll see you next time.